Hello. This time around, I'm going to try and condense this circuit into your mind or into your head. I want you to really understand what you are saying, from the microcontroller to the clock, resistors, LEDs, voltage regulators, batteries, and every single wire here. You should know why they are there and what they are doing, and understand how the entire circuit is connected, so that apart from being able to replicate other people's circuit, you should be able to design your own circuit from scratch so that other people can follow or use. For example, if you want to manufacture or mass produce or make a prototype of a brilliant commercially viable idea that you have, if you can design the circuit well, put all the values, put all the components, connect all the wires properly, you can send that circuit to wherever in the world, and they will be able to interpret your circuit diagram and then send you a finished complete product, and hopefully working too without you having to go to the manufacturer. You don't have to be physically present there. All you need is just send your circuit diagram halfway around the world, and then you get a working product in a few days. How is that possible? It is because of this thing you are seeing right here. Alright, in our case, it's a very simple application. It's just to flash an LED, so we don't really need so much components. But as small as these components are, they are capable of doing a lot of things, and they can actually do a lot of useful things, especially this guy here. This is my controller. My controller is a very powerful computer. It's not very powerful, like very powerful, but it is small but mighty. It can do a lot of things even as small as it is. Alright, so but what we're using it for here is just to flash an LED on and off. To do that, first of all, we need an LED. That is correct. We have to. If you want to flash an LED, you need an LED. And who is going to be flashing the LED? The microcontroller. But how are they going to be connected? It's simple. We would have connected the microcontroller straight to the LED, but we decided to put a resistor in between. And if you took our basic electronics course or getting started with electronics course, which was a prerequisite for this course, you will know that it is important you always put a resistor in series with an LED to protect the LED from taking too much current. Right? So that's why this resistor is here. As for how did we get the value, the same thing. The getting started with electronics course will teach you how to get the value of resistor. And if you've taken that course, you will know that this value of resistor is good enough to protect our LED. It is a little bit higher than the calculated value, but it is allowed to use a higher value, but it is not allowed to use a lower value. Provided you can use a higher value, provided the LED is visible. The light is still visible as much as you want. Now, why did we choose to use pin 23 of all the 28 pins that this microcontroller had? Why is it that it's pin 23 we now came to choose? There must be a reason. You can't just choose any pin as your output pin. Alright, the first thing you look at is which pins are available, right, to function as input and output. It is available in the microcontroller data sheet, but for simplicity's sake, pin 20 and pin 8 and pin 19 are already dedicated to power supply. So you already know that out of the 28 pins of this microcontroller, pin 28 and 19 are not used. You cannot use them to flash the LED. So the power pins are out of it. The next pins that we need to eliminate are these three pins here: the MCLR pin and pin 9 and pin 10. Why? Because they have dedicated functions. They are not used as input and output pins. This is for reset, and these 9 and 10 are for the oscillator. This is where the oscillator sends pulse into to drive the microcontroller. So the only pins that are available for us to use for input or for output are these ones here: pin 2, 3, 4, 5, 6, 7, pin 21 to 28, and pin 11 to 18. So therefore, we can use any one of these 8 pins, any one of these 8 pins, or any one of these 6 pins for what we want. So you see now that we've narrowed down our choice area to these pins, or these pins, or these pins, to any one of all these pins here. So I could have I just decided to choose 23, pin 23, just because I just felt that there was no specific. That is all. I could have chosen any one of all these ones here, and the system will still work. But pin 23 seemed like a good pin. And number 2, there's another reason why I chose pin 23. Why I chose there's some other pins that you cannot choose, for this application based on your level. The truth is, some of all these IO pins work as analog pins as well. They have the ability to work as analog pins, while some of the other ones only work as digital pins. If you decide to put your LED on pin 2, for example, which can work as an analog pin, you will have to tell the microcontroller that you are using that pin 2 as a digital pin only before you can use it successfully. So I didn't want us to go through that headache of worrying about how to tell the controller that we want to use the pin as digital. Therefore, I completely eliminated all the pins here. I don't want to use any one of them. Even this pin 6 that does not have analog beside it, it cannot send out pulse. It cannot send out voltage. It's only designed to receive voltage. So we just eliminated all this one out of it. And then, so we actually have only these ones to work with. Only these ones. So you can now choose any pin from among all these ones. Any one you like will work for the same reason, for the same thing we're doing. Any one among these ones will work. So I just decided to choose pin 23. So that is how I chose pin 23.